here we are. So, so Sarah, we hadn't gotten yet to Tarkett and hearing about, first of all, what it is. It's a flooring company. Can you talk a little bit more about that? And then the circular piece of that. But what is Tarkett?
Sure. So Tarkett is a global flooring manufacturer. Our product offerings include carpet, luxury vinyl tile, vinyl sheet, vinyl tile, linoleum, rubber, stairwell systems, flooring accessories, artificial turf, as well as athletic track. Quite a mouthful. Over the last decade, we've done a lot of work to address environmental and health issues alleged to flooring products.
So I imagine, given that this is the built environment, whether it's the buildings or everything that goes inside of a building, that a lot of the concern is around air quality.
Absolutely. The built environment has been under pressure to improve its health and environmental performance as interest in healthy indoor environments grow. Since indoor air pollution can be up to 5 times greater than outdoor air pollution, and with the rise in asthma and allergies, improved indoor air quality has moved up the public health agenda. And as a result, policymakers, consumers, architects, and NGOs are wanting greater transparency on the health and environmental profiles of building materials as they seek to understand the impact of certain finishes on human well-being. In addition, green building certifications such as LEED, WELL, and Living Building Challenge are making material health an integral part of their scoring systems.
So this goes very much to how you choose materials. What's changing in terms of how you think about materials? What are you doing differently? Are there new screens? Are there whole new materials and suppliers? How is circularity shifting your material selection?
Absolutely. I want to go ahead and kind of talk a little bit about our cradle to cradle journey, which started back in 2011. And to date, 98% of our materials, more than 3,000 ingredients, have been assessed. Material health is a critical building block for cradle to cradle design. We believe screening every material thoroughly for hazard risks can help to create greater transparency and improve human health. And this is achieved by reviewing every chemical against regulations such as REACH, as well as green screen list translator.
How many chemicals are we talking about, Sarah?
As far as Tarkett is concerned?
That you've reviewed, yeah.
Oh, over 3,000.
Wow. Okay.
Yeah,
sorry, go ahead.
Which is about 98% of our materials. Then there is an assessment conducted by chemists, and they help us to understand an ingredient's potential risk and provide a comprehensive evaluation of chemical hazard profiles. Chemicals and materials used in the product are selected to prioritize the protection of human health and the environment. And then lastly, optimization. Once a product has gone through a full assessment process, it is positioned to phase out chemicals of concerns to replace them and alternatives that have been assessed to be safer.
Yeah. So Stacie, is what Tarkett's doing in terms of reviewing 3,000 chemicals and really everything, is that becoming the norm, or is that still sort of exotic, cutting edge kind of thinking?
Well, actually, it's somewhere where the thinking, if it isn't, should be going, because if you look at materials and selecting those materials, no matter what product you're making or what process your company might be involved in, chemicals are really the foundation of everything, whether it be a chemical substance itself, a chemically formulated product, or a manufactured article. You know, chemicals are the basic building blocks of all of that. So if you take a closer look and really look at the profile of the chemicals that are the foundation, that will give you much earlier insight and any red flags and considerations you should keep in mind about selecting that material as your foundational building block. So for instance, the things you really want to assess are very much exactly what Sarah was talking about. What's the inherent hazard of that chemical substance? Is it persistent, bioaccumulative, toxic, all of the, persistence and very bioaccumulative, or even now persistent, mobile, and toxic. Even aside from the inherent hazards of that chemical, some of the ways you do that, as Sarah mentioned, are looking at chemical classes or categories. So for instance, not just a specific chemical, but if you're evaluating something, is it of a chemical nature or chemistry that puts it into a class of chemicals of concerns, such as perfluorinated or halogenated, et cetera. as well as that, when you're looking at these materials, you have to keep in mind that in a circular process, if you're looking at risk in one use scenario, so you're looking at the inherent hazard, you're looking at how you're using it, and that determines risk. Well, the risk may be low because the exposure could be low. If it is in a circular use, what is going to change about how that material is used that could change the exposure? So you should really start looking at that type of a future lens.
Right.
That's something to keep in mind, I think, very important. Not only just what's the hazard of it in your use case, but in a circular use, how can that hazard impact human health and environment?
So do we have enough information about these chemicals so that we can answer all of the questions that you're asking?
We're building that information. If you see the way trends are going in regulations, many of the governments are scrutinizing new chemicals very closely, more closely than before. There are schemes in place to look at what's already out in commerce with a closer view of hazard and risk, more risk-based. Also, as you'll see, there are other kinds of regulators. Retailers are regulators. They've got their own lists of restricted substances. Consumers can be regulators because of either perceptions or their understanding of a substance that they don't want in a product that they're consuming. So even in the immediate use, and then if you're considering a circular use, those are things you have to keep in mind. So there are additional ways of assessing hazards that we did not have before. There's a trend to get away from animal testing, but there are many more alternatives to animal testing being developed right now and put forth for the chemical industry to use to assess these hazards.
Yeah. So Sarah, let's talk about this with a floor tile product, modular floor tile that you've worked on, and how did this come together? And how does that fit in terms of people want to know, are you taking this back? Are you repairing it, replacing it? What actually are you doing?
Sure. So today, carpet represents 3.5% of American landfill waste, which is about 4 billion pounds per year, which is worth $5 billion.
Oh.
Yes, it's shocking actually, which is one of the reasons why we developed Ethos Modular Carpet Tile. This product fits in our circular economy narrative in two ways. Ethos, which is the carpet backing, is made of recycled windshields, a polymer called PVB. So we are diverting this glass from the landfill as well as diverting our product through our Restart program. Every year, more than 15 million windshields are replaced in the US. That's about 600 million pounds of glass that goes into the landfills, with the average cost around $220. That's a value of around $3.3 billion a year. So the consequence is that a large amount of valuable material is lost. And of course, in the landfills, these products biodegrade very slowly, can leach chemicals into the ground, and contribute to emissions. So we design our flooring to have a long, meaningful life. And at the end of use, we strive for our products to be repurposed back into new flooring or other outlets through a Restart. We are the first flooring company to begin a functioning program like this, and it's been around for a little over 20 years. This year, we actually brought back 2 million pounds of post-consumer product this year, mostly carpet as well as some vinyl.
Yeah. Well, let's talk about vinyl, because vinyl is an interesting topic. I'll hear from you, Sarah, and then from Stacie about how to think about materials like vinyl, which are, or I guess that's polyvinyl chloride, which is a problematic chemical from a health perspective. And you're using that, I guess, for the carpet backing or the tile backing. Sorry, correct me if I'm wrong there. How do you think about that in terms of circularity, and what can you actually do with used vinyl coming out of when a product has to be taken off the floor?
Sure, absolutely. We take it from a perspective of using PVC as responsibly as we can. We do pride ourselves on having a very broad portfolio as far as our flooring is concerned, and we do have different clients that have different requirements. What we do with the PVC is that we can pelletize it, and that's what makes material health so important, is knowing the chemistry of your product and what's in it so that you can reuse it for circularity.
So, Stacie, PVC isn't the only chemical of concern here that ends up in products. How are you thinking about these kinds of products and these kinds of ingredients in terms of engineering them out or keeping them in play? What's the strategy that companies use? I'm sure there's more than one, but how do you view this at UL?
Well, we have kind of a unique perspective at UL because we're an independent third party. So we're not a chemical industry, we're not a government authority, we're not an NGO. So we work with a wide cross section of industries and entities. We work with governments, et cetera. So our lens into this is broad. And what we see a trend toward is in order to engineer these things out, you kind of have to know if they're in what you're sourcing, which is sometimes a struggle. If you're sourcing materials from suppliers, being able to know exactly what's in them, not just the substance that you're sourcing yourself. And that can be as an ingredient for something you want to make, or it can be as a feedstock for your process to create a chemical or even a processing aid. So it's important to know what's in what you're sourcing. And that includes any potential impurities and byproducts in your manufacture process to really understand the full profile of the chemical that you're working with. And so what we encourage companies to do is two things. One is communication and transparency in the supply chain to the greatest extent possible is key. So even if you can't get 100% specific chemical identity of something, it's proprietary, be able to ask the questions that answer the metrics and attributes that you need to know for your circularity goal, absent getting the chemical identity. Also, another, real strong strategy, I guess, for what we encourage people to do is embed circularity concerns in your design process. So as you're selecting materials, as you're evaluating formulas, processes, manufacturing methods, all of that, think about the material selection, the qualities of the chemicals, the attributes, put that in your design phase so that you're not maybe going too far down the path and then only to come back and realize that you're hitting a roadblock with circularity because you forgot to consider something. So we're really trying to educate companies to embed circularity and material selection in part of the design phase.
Yeah. Well, let's talk about the roadblock, and I want to hear from you first, Stacie, and then Sarah, and then the clock is going to start ticking them down. But I've asked and had answered all the questions about what's in my products, with all the ingredients, all the chemicals, and there's one principal chemical that came back, which I understand exactly what it is, but I can't find a substitute for that in a way that's going to be it cost comparable or performance or anything else. There may not be a healthier alternative, healthy either for people or the environment. Right. How do you think about that when you hit that kind of roadblock, Stacie? And then Sarah, I want to hear from you.
That's a great question, and I think a lot of people probably struggle with it because it's very case specific. So let's say, for instance, if that chemical is critical to national defense or some other critical application, and there really is no viable direct alternate, or the alternate creates additional or different problems in and of itself. Sometimes at the moment you have to go with what's the best available alternative. Another way around that is there a different technology that can be applied? Can you think outside the box, and instead of focusing on finding that substitute, is there a different technology that can be applied? So that's why it takes a lot of very forward thinking in these types of decisions, because oftentimes there really is not a suitable alternative. I think a lot of people run into that with some of the chemistries that bring us many health benefits or protections as humans in the environment, but yet can contribute and cause problems for circularity. Yeah. So it takes a lot of research and a lot of effort and decision making.
Yeah, Sarah, in the brief time we have, you run up against that? There's a problematic ingredient. We know exactly what it is and where it comes from, but we also know we can't find a substitute. And how'd you work with that?
I think Stacie really hit the nail on the head there. We have certainly had challenges like that, and what we found is that we needed more investment. We needed to do more research. We needed more R&I working on this project. I think Stacie said it very clearly. You really have to think out of the box, look at new technologies, and see possibly if there's any other alternative that you can use.
Yeah, well, this is so much to talk about here, and no more time. And I'm sorry we had a little bit of a late start, but there's more stuff happening in a few minutes, so got to clear the decks for that. There's a lot of great conversation going on in the chat box too, and including some great resources, the Cradle to Cradle Product Innovation Institute, and some of their databases. Of course, the great work that UL is doing across a whole range of products and services in this area. And so I encourage you to check some of that out. There's also a survey that we always appreciate if you could take a minute to fill that out. And there's just this is a huge topic that we've barely scratched the surface, but for now, I just want to thank Stacie Abraham from UL Underwriters Lab and Sarah Enaharo from Tarkett Flooring Company for just helping set the stage for this and more conversations to come. So thank you all.
Thank you.
Thank you.